All right, so let's do some more stuff on stack length. So first thing, from last time I added the string concat and string substring functions. I thought it's gonna be pretty easy to just port them from cool language. And I'll be honest, the substring one I got it first try, which is pretty surprising. Concat one I had to debug it a bit, but yeah, I mean, it was the first one that I ported, so obviously I had some issues. But now we can actually do pretty much anything with a string if you think about it. We don't have compare yet for strings, so we cannot use them in ifs, but we can substring them and, you know, get stuff from inside the string. We can concatenate multiple strings, and we can also output strings. Yeah, I guess equals is missing on strings, but I'm gonna leave it for now, and we'll try to do equals maybe when I implement the traits, if that's gonna be possible. We'll see. But yeah, I mean, I have a few helper functions at this point, right? And I want to move them into like something like standard library. But we'll see how we can do that in a bit. For now, what I want to do, like the first thing, is let's try to implement, because if you notice, string.out is actually just printing strings. It doesn't work with numbers anymore, right? So if I do string.out on a number, it's I mean, obviously it's gonna work. Let me just but you know, doesn't really work because it doesn't do anything, right? We print the status code here. If I do something like this, right, it doesn't print the number, and I'm surprised it doesn't segmentation fault, but that's beyond the point. And ideally we would catch this as a type checking error, but we don't have any types yet. We'll also do that. I mean, hopefully we'll have like a really big part right there, because that's gonna be interesting to do in this language. And yeah, let's actually try to have something like show, right, for a number, which converts it to a string, and then we use string out. And I'm gonna keep the convention for now that integer is gonna be the like functions for integer won't have any prefix. For example, you can see that string has the prefix, but yeah, I think I'm gonna keep it like that for now. So let's try to implement show for integers. I'm still gonna do type checking, like, yeah, the types, because I feel like it's gonna be useful once we have them. So yeah, how is show gonna work? Right, that's a good question. So if you, oh yeah, and some other things that I added to make our lives easier at this point. Let me just scroll through this entire assembly crap. I added modulo. Well, actually, it's not really modulo, it's more like the remainder. So I had to implement modulo by using the remainder, right? So yeah. And some other things that I added and are interesting, I don't think so. Maybe, you know, division, but I think we saw that, and subtract. Yeah, probably. I don't know. So the point is to modulo by 10 the number, right, to get the last digit, and then to divide by 10 to remove the last digit. So we'll have to see how we can use these two operations together with if and calling recursively to show, right? So we'll have to see how we can use these operations to implement toString, right? And I mean, if you know, already think in advance, you'll see that it might look a bit problematic because modulo by 10 gives us the last digit, not the first one. So you'll say, oh, but we'll build the number in reverse, like it's gonna suck. But I think there is a technique in recursive calling which if you, let's say we have like, now I'll do a bit of an explanation of why this thing can work. So let's say you do something like some operations and then you call recursively to show, right? This thing is going to be executed first and then call to show again. But if you do the operations at the end, it's like working in the reverse order, right? So we'll try to do that actually. Right. So first things first, let's do the base case, which is gonna be if the number is less or equal to 0, so not greater than 0, I guess. I mean, yeah, if the number is 0, so let's do something like dup 0 equals if. So if the number is 0, we are in the base case. So at this point, we still have an int on the stack, right? So let me just write else and v. So at this point, we still have the number on the stack and here as well, right? We have on both cases, we have the number on the stack. And what can we do with this number? So if it's 0, we don't want to do anything, pretty much, right? We want to stop. Or I guess, oh, and maybe another thing that we need is that, well, I think we'll need another function that will also take in a string as an argument. Because if you think about it, I mean, it should work even without it, right? Because if it's 0, then we might want to do like an empty string or 0, but I'm not sure, right? Because this is like the first call, right? On the first call, if you have a 0, then you put, but let's see. Right, so on the else case, what we want to do is to duplicate the number. So now we have n. Let me just, I guess that makes sense. We duplicate the number, then we mod. So we have n and the last digit, right? Then we swap. So I have digit and last number. And the reason why we swap is because now we should call to show, right? And let's imagine that show already works, right? It already works. We can just call to it. And I think this is the main point when you do recursion. You have to imagine that the function that you recursively call already works. So we think that, okay, it's going to return d and the string that represents the number. So it just works. It's magic, it works. And if you think about it that way, it's going to be much easier to implement it, right? Because now we know, okay, it works. We just need to implement this step. So we swap again, s and digit, and we kind of have to do the digit to string now, right? And then concat. So maybe we need another function for showing a digit. So show, maybe I'll do like digit.show, which is int string. So we can have stuff like, oh, maybe it's going to be dup 0 equals if we do a 0 and then else. And it's going to be something like this, right? 1 shows 1. I think it's gonna be like this, right? So we duplicate the number, we do 0 equals. If that's true, we do 0. Otherwise, duplicate again. Yeah, I think this should be fine. It looks a bit weird, honestly, but I think it should work. We can even just test it, but now we need to put fizz for each if. So 1, 2, I mean it's 10. Shit, do I have 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, exactly 10. Holy shit, so lucky. I think that's right, and we don't even need the last else, but it looks nicer. So I think that's how you do digit show. Let's just see what happens if we do digit.show string.out and we do like digit 4. Okay, it shows us a 4. I mean, I shouldn't print the status anymore. I think we are past that, but it shows us a 4. And if I do a 7, it shows us a 7. Pretty cool, right? So at this point, we can do something like digit.show. So now we have a string and the last digit is now a character, right? And I think we can just do string.concat to get a string. So I think that's all. And now if we do show on, for example, 69, it should just segmentation fault, obviously. Oh, you know, I forgot to do the div, right? Div 10, which is gonna 10 div, which is gonna do d and n prime, kind of d and n prime. So here we do show on that n prime, and yeah. Oh, I said div, it should be slash. Still segmentation faults. Okay, we can think about why that happens. So we dupe 0 equals, if that's not gonna be the case, we are gonna go on the else case. We dupe the number, we modulo the number, so we get the last digit. You know what, let's see what happens if I just call mod. If I just call this thing, it's gonna show us a 9. It doesn't show us a 9. What? Okay, that's strange. Dupe 0 equals if. I mean, okay, here we can do like pop or something, but that's not really the case. So why doesn't it work? So here we duplicate the number. Right, we still have it, but it's not gonna be 0. That's what I mean. So here we can do like this and string.out, and it should show that string, right? So it comes here. So if it does modulo and then digit.show, it should generate a string. So why doesn't it do that? Let's do it as a return code for now. Apparently we still use, oh, what? Oh, what? This is a bit weird. Why does it? Let me just put like a 0, right? And maybe I made some mistake with mod. Oh my god. Yeah, I'm like, why doesn't it work? But I forgot to put the arguments to mod. It should be 10 modulo, right? Probably someone was yelling that I need to do that. Okay. Oh, 0, 0. Okay, so at least let's do again a digit show. So here I'd expect to see a 9. Okay, let's remove the status. Yeah, and I see a 9. Okay, makes sense. So we have n and digit, digit and n, digit and n prime. I do another show. Let's it shows a 0 like this. What? Interesting. What if division is cooked for some reason? Let's do 2010 division. It should say 2. Yeah, it says 2. So, okay, division is fine. I thought maybe I mistook the order of operations. Let's do another modulo at this point to see if we get a 6. Wait, why did it show 6, 6? Ah, because I also do the status code, yeah. So it's a 6. So that thing works. But then, so I duplicate the first number and I get the number twice. Then I modulo by 10, so I get the last digit. Swap them around, digit and number. I trim the number down, so it's gonna be like 6. It's gonna be like 6. It's gonna be like a 6 here, so 9 and then a 6. They are both numbers. If I call show on that, damn, yeah, it's really strange. It's gonna be like again like a 6. Let's say, okay, we have a single number like 9. What's gonna happen with that, right? What's gonna happen with a single number? Well, it comes here, it does modulo, so we get 9. Division is gonna be 0, so it's gonna return an empty string. So what happens if I do just 9? It shows me a 0. What? But what if I do, for example, empty string concatenated with 1? Is it like gonna be a 1? Yeah, it is. So even if I do like 6 here, like it still works. I guess it's okay. Let's do GDB because I cannot figure it out. I don't know why. Let's run it. Sadly, it didn't work first try, so yeah. Okay, so let's. I think I have to step instruction into this one. So we have a 6, right, into RDI. Here we push it on the stack, and then we call to this show function. So let's see what happens in show. We do push RBP, whatever. We call a function immediately, so dupe. So I expect that now. So the stack is somewhere here, but for with a 0. So if we examine like 32x, wait, what? Yeah, I guess these are the memory addresses of the 6, right, in static memory. So it's 402050 or something. So if we examine 1D from 402050, it should be a 6. All right, so yeah, we know that. So now we put the number into RAX. We call equals. So in RAX we should see a 0, I guess, or not yet, maybe. Maybe this is actually equals. Yeah, so it's a 0 because it is what it is. Right, we get the boolean. Okay, so now if we check out this thing, we should also see the boolean that was allocated. Or something. Why does this look? Oh yeah, no, the boolean is here now. Yeah, it's 413000. Okay. So if we go next, it shouldn't jump, so it should go on the else case. Makes sense. First thing it does is call again to duplicate. So I think we should see in RX again 6. Yeah. It puts a 10 in RDI. I can see that. And it pushes it on the stack. So now if we check out this thing, we should also see, I guess we can see that 6 is twice, and I guess this is the 10 that we allocated. So if we go next, it loads 0xa, so that's 10 in RAX. Wait, what? Wait, what? I'm a bit confused of what happened. Let's examine the stack again. So we get something here. Let's examine one number from x413008. Oh shit, what? Oh, it's examine one number from 0x413008. So it's a 6. That makes sense because the result of modulo should be 6. Right? So if I do that again, okay, and why this is another number? I guess now it divides by 10 or something. Oh, but that was like swapping. So we have 6 on top of the stack at this point. And D is this one actually, I guess. Forty-one 3008. So 6. And the other one is 0x 40 20 50. Okay, so another 6. That's good. 40 21 10. It's a 10 allocated on the stack. Right. And then 41 30 10. What is that? It's a 0 for some reason. So we have basically 6 6 and the 10 on the stack, and then a 0. I don't know why that 0 is there, but so I guess if we do division, which I think it was that call, stack should still have all of this crap, but I think that 41 30 08 is still 6, and 40 20 50 is still a 6, which is weird. 40 21 10. No, I'm a bit confused now at this point. I don't know if I called. Damn it. Let's run. So annoying. Step instruction. Next. So this is the push int, right? This is show, so we get in. This is the call to dupe. So if I check the stack, I should see the same thing twice because it was duplicated. Right? Now it should be push 10, right? So if I check the stack again, it should be here. This is a 10. Zero x. Why is it a 0? Oh, I'm stupid. Yeah, it's 0 because here it's 0. And I guess if I do another next instruction and we check again the stack, it puts something here which is probably should be like false, right? Yeah, but what's this extra call now? I guess it's a pop. So if I do this one, yeah, it was a pop. So now it takes the value, it does the if, it doesn't jump, so now we have the first call, which should be again dupe. So if we check the stack, we should see again the same thing twice on the stack. Yeah, it's a bit annoying that the stack is not reset to 0 once you pop. Maybe that's something we can do to make it easier to debug, but the stack should now have the same number twice in the beginning. That makes sense because it was a dupe. Now we should load, after this one, we should load a 10 here. So if we examine one digit, yeah, we loaded a 10. So now the next call should be modulo by 10. So if I call this one, what should we see on the stack is a 6 here. So if we examine one digit from 0x413008, it should be a 6. Sorry, yeah, a 6 because that's the result of modulo. So now we swap. So we should just see that these two are swapped around, and yeah, they are. So next step is to load a 10, divide by 10, divide by 10. So if we check out again this thing, this should still be a 6. Right, so if we examine 1D from 0x413008, this is the digit 6, and 0, 40, 20, 50 should be what? It feels like something is weird. It should be 0, 41, 30, 10. Did I make a mistake with the division? Did I make a mistake with division? Oh, no. Because I popped these things. Yeah, I popped them, so shouldn't be a mistake there. But look how many calls there are. That looks a bit weird. So this was a push. Oh no, this is the division. So it's fine. If I do next instruction, is what I meant. Now we should see something different here. We should still see our number, right? This is still the digit, but now this looks like the next memory address. So if we check that out, 413018, it should be 0, yeah, and 08 should be still 6. So now we call to show with a 6 and a 0 on the stack. So a 0 on the stack basically. So if we step instruction, we are back at this one. So we put a 0, we call this one, call that one, we get the true now. So jump is taken, should say, yeah, jump is taken. So we put, what's this one? Something with 0. I'm not sure what's that doing. So I can empty string. Let me just check what's in example asm for the show function. So it fits an if we put, oh, so we put the string constant empty and then we push. I mean, yeah, I guess so. So string constant, which one? 21. with length 0 and everything is yeah, I mean, I guess so. Example, so yeah, and it returns. So this one pushes the thing on the stack. So if we check out the stack now, we should see our old number. Shit, this is the 0. And this is what? 0x 40, 21, 18. I think this is the... I think that's the string, 40, 21, 18. So this is gonna return, right? And now we are on the swap. So if we swap and we show this thing, it swapped around these two. So I think I forgot to pop here. Right, I think we should pop there. Let's make, and let's run this one again. Okay, now it's a 6. That's interesting. Fuck. Because I think we should pop this number and convert it to a string basically, but it looks like it still didn't work. Damn. Break start. So if I run and just go like next instruction, step instruction, next. No, it should be like next step instruction. And now inside of main, I do a push. So we pushed 69 basically, you can see it here, it's E. And now if we step inside of show, we duplicate. So do I have, yeah, I still have this. So we duplicated our number. That's good. Let's see if we can actually see the number. So digit 0x 40, 21, 28. Yeah, 69. Perfect. So we next instruction. We can just next this because we know it's gonna be false, right? Would be really interesting to figure out how to add symbols so we can actually see the function names. That would be nice in GTB, but anyway. Well, we know that here this one does modulo. So if we check this thing, this should be the result of modulo, I think. So examine one digit 0x41 3008. Yeah, it's the result of modulo. Nice. So here we swap them, so we should see them swapped around. That's cool. Now we should put a 10 and divide, so we get a 6 back. I can see that. So if we take a look at the stack now, we should see the number like 9, that's the digit, 41 30 08. Oh, examine one digit, right? And the next thing on the stack is 41, 30, 18, which is 6. So if we step instruction, that was push, that was divide, so this is show, right? You can kind of tell it's show because it's the same offset, but yeah. So we go again, we put probably a 10 somewhere, or like a 0, sorry, 0. So we compare, it's gonna say jump is not taken because it's on the else case. So how does the stack look at this one? So now we did the division again with the 10. So the stack should have 9, it's still here. And it should have another digit now here, and the result of the division here, right? That's what I would expect. So one digit, 41, 30, 0, it should still be 9. 41, 30, 28 should be 6. And 38 should be 0. Yeah, that's exactly what I would imagine. So now if we step into this function again, into show, it's gonna go, and here it's gonna say jump is taken. Yeah. So it goes on this one, it pops the whatever, it moves the string, and it returns. So if we check again the stack, we should again see our number 9, we should see 6, and we should see a memory from the static memory basically. So examine 1D, 28, it's 6, nice. And if we look at the length of this string, it should be 0. Yeah, so we are now at what? At swap, kind of. So we swap no, I mean, yeah, we have basically, if you think about it, we have a string, like digit and string on the stack, right? So we want to swap, make a digit show call. So let's do swap. So if we take a look again at the stack, we should see that our 6 is here now, right? That's the 6. Yeah, so 6 is first, and then the empty string is second. So now we call to digit show. And what digit show is gonna do? Let's just call it like that, and let's check the stack. What? Why is it still here? Like, it looks like it just added a new thing on the stack. Really? It has length 1. Oh. Oh, whoops. So if I do that, oh, it's here. So if I do it 8 and we check to examine a string, it's gonna be 6. Oh shit. So that means we don't even, but I want to dupe. Right? Because otherwise we lose the number. So because if I do 0 equals, that number is gone. So it means I have to pop here every time. So if it's true, we pop the number and we go. Otherwise we dupe again. And on the like else case, if you know it's impossible, we just pop. But it also needs to return a string, so it's like empty string, I guess, just to satisfy type checking. Okay, maybe that's what happened, right? Because you can see that now we have 4 items on the stack, and basically this thing did this, so it added an extra D unexpected to us. So let's run this one again and get 69. Finally, dude, finally. Ooh. This one was a bit harder than I expected, to be honest. But it actually works, kind of. I mean, what's not gonna work, if I'm being honest, is printing 0. This one is not gonna work. 10 works, but if you do 0, it's not gonna work. And why is that? Well, we do here check if it's 0, then we just pop and return nothing. But if I put a 0 like this, right, it's gonna work for 0, right? Oh, it works for 0, nice. But if I do like 1 2 3, it's gonna say 0 1 2 3, right? So that's not that great. So maybe what we can do is maybe keep this one, and we could add an extra if statement here, which I don't really like. Like, I would rather do something different. I would rather have function show prime, right? And show prime is gonna do the thing, right? And then in here we can keep the edge case in the show function. So what I'm gonna do actually is go here. If we get a 0, we just show a 0, and if it's the edge case, like if it's the normal case, we just show prime, right? So that's how I would actually do it. Let's just make this function a bit more pretty by removing the comments. So now no one will understand what this function does, basically. All right, it's GG. It's like you do a commit on, I don't know, if you think about it, right? So yeah, now we check. If we get a 0, we show a 0, and if the number is anything else but 0, we just call to the normal show function. So now this shit. Oh, yeah, because we call to show again. Okay, 1 2 3, right? And 0 is gonna be 0. That's nice. So obviously, right, so now we prepare ourselves for the Google interview by implementing FizzBuzz. And yeah, I mean, the idea is we'll get a number which is gonna be the end, and we don't return anything. So yeah, we imagine imagine like you are in a Google interview and they ask you, okay, let's implement FizzBuzz, and you're like, you pull up the stack language. Okay, anyway, or like you pull out your own programming language, you know, and implement it. But you have to think of like implementing a language in such a way that makes the problem that you have to solve extremely easy, because probably solving FizzBuzz is not going to be easy in stack language, but you get the point. You try to make it as easy as, I don't like, imagine doing that. That would be pretty funny. So, you know, actually here we get the n, right, which is the ending, but we also kind of want to have an iterator. But I like to have a like a function that's like an interface. You can see it here. You have show, and then whatever, show prime, like who cares about him, it's like ugly and internal, right? So FizzBuzz is going to be our pretty function, and then we need a FizzBuzz prime, and this FizzBuzz prime is gonna take in the iterator and the ending, right? So now we have to do some stuff. First, what do we have on the stack? We have the iterator and the ending. So obviously we care about this I, right? So we want to swap, and we are gonna get n and I. And how does FizzBuzz work? You have to modulo by 3, 5, and 15 or something. So obviously we need to duplicate the I because we want to modulo by let's think, if we do modulo by 3 we print fizz, if we do modulo by 5 we print buzz. So you can just do something like 3, and I'm gonna do mod because I think mod is better. So we do modulo by 3. If that's true, so it's gonna be just an if case. I guess we string out fizz, so we have to, I guess let's do that. So at this point on the stack we'll have a boolean, right? Ni and boolean. So if it is true, then we do fizz string.out. Right, and at the end of this function, of this if statement, we'll have n and I on the stack. So then we can do 5 mod and oh, I guess 0 equal, right? I forgot about the important part. 0 equal, and we get a boolean. But we have to also duplicate it before that. Right, we have to duplicate the I and then apply mod and check if it's equal to 0. And if that's true, we print buzz, right? And then if I guess else case for both of them actually. Well, maybe it's easier if we do if else and just focus, like not try to make it cool, because at this point I need to check 2 things. I need to check that it's not divisible by 3 and 5 at the same time. Or maybe it's gonna be easier to just do if else. Right, like put this entire thing in an else. And then actually also do 15, which yuck. But because here I need to check that it's not divisible by 3 and not divisible by 5. Or I guess or divisible. But I don't have or yet in the language, so okay, let's do it like that. Let's do all the cases, even though I don't like it, but so here it's an else. I guess I'll do it like this. Else comes there. So on the else case, we do this part. Right, and then we have another else, and we do another if, this time with 15, and it's gonna show FizzBuzz. I guess if I just remove these comments, it's gonna look a bit better. Right, so if it's divisible by 3, we show fizz. If it's divisible by 5, we show buzz. If it's divisible by 15, we show FizzBuzz. And on the else case, we do show string.out, and maybe also new line concat, so we can have a new line as well. So I think this is actually gonna be FizzBuzz. Oh, and actually we don't even need to swap, because I'm gonna do 0 FizzBuzz, or I guess 1 FizzBuzz, because yeah, right. So this is, but this is only one case. All right, and we need to recursively call to the other cases as well. So maybe what I actually want to do here is have like FizzBuzz. This is the FizzBuzz case. Maybe we can even do like, I don't know what character can like end. For some reason I chose and you cannot do anything about it. It is what it is. Oh, and another cool like a thing that we have to not forget is to pop stuff, right? You remember that I spent an hour in GDB because of dupe, so let's not forget about popping what we dupe. Okay, so then FizzBuzz prime is the one that actually does the loop. So let's see, we'll have, maybe I want to swap, right? So when I call FizzBuzz prime at this point, wow, I really need to implement the Vim highlighting because it's crazy. So if I do one swap, we'll have 1 and n on the stack, right? So here we can just say if it's less than, if, oh, I guess I want to do some things first. I want to swap dupe swap. No, not swap. So if we swap, we'll have n and I on the stack. Then I dupe because I want to keep 2 i's. All right. Then I mean, I guess I want to keep n as well twice, so maybe I can just dupe even beforehand. So it's n I, then we let's say we rotate counterclockwise, so it's n I n, but I want to put, okay, what do I want to reach is I NIN or something. I want to get this format. So if I rotate, like I don't really care what I get, I want to have 2 of them like every time. So I could rotate counterclockwise, so I get NIN, or I could rotate clockwise and I would get NNI. So I dupe NNII, rotate again clockwise, so it's NIIN, right? And now I can make this comparison, so I'll get N and I. All right, so after that, if it's true, I can call to FizzBuzz end, and this is gonna remove the I from the stack and only leave me with N. And then I can call to FizzBuzz prime, but not yet because I lost my I. Yuck, I lost the I. So let's actually dupe. So at this point we still have the I. I can do 1 plus to go next, and then call, and then actually call swap, and then call FizzBuzz prime. Right, so this thing takes the I, it does whatever with it, and then we add 1 to that I, and we call the recursive function. And what? So here we still have N and I. But after this thing, we have nothing on the stack. Here we have what on the stack afterwards? N and I. And here we don't have anything, so we need to pop. I think that's 50 FizzBuzz. Okay. Yo, it's actually working, what the fuck? Oh. Okay, I failed the Google interview. Okay, I'm aware. I should have put this one first. Let's put them like this, right? Because otherwise we fail the Google interview, and we don't want to fail the Google interview. Right. So, but why did it segfault at the end? Oh, because I need a return code. Yeah. And now we are Google engineer. Like, I mean, what can I say? It's doing FizzBuzz. I mean, this is, you know, the real test is gonna be to do. Oh my god, I almost said advent of code. Please don't, like, let's not do advent of code in stack language. That's not gonna be fun. Yeah, I want to say like rule 110 or game of life. That's what we actually need to implement to say that it's working, basically, right? Okay, let's remove the useful comments. Actually, they were quite useful, if you'd ask me, but it somehow looks much cleaner. If I just do this, for some reason it's like one-liner. I mean, not really, if you think about it. We have this entire crap. But it's kind of doing FizzBuzz. I mean, right? Am I right? Like, it looks good to me. I don't know if it should start with yeah, I mean, oh, and we can do, because we want to have less than. Someone says, why don't we do less than? Well, we could just define the function that does less than, because we don't have the function yet. So will this one work? So if let me just think about it, because if we do less than, it's gonna consume both integers. I need another function dap2, which takes into a's, and actually, oh, I guess it's ab, and builds this construction, right? And the idea is this function, we can just implement it with this language, because why not? So I'm gonna do, if I call dupe, so we have ab. If I call dupe, we'll have abb. Let's rotate clockwise, why not? bba. It's already not right. Probably I should swap first to be able to do this thing. So this is gonna give me b and a. So now I duplicate b a, I rotate a b, I duplicate again, so it's a b b. And how about rot prime ab, right? That's how it's gonna look like. I think that's how it's gonna work. So yeah, it's gonna be interesting to do type checking even on this one. Like, how is type checking gonna work? That's gonna be interesting. But now we have this dupe2 function, which is gonna be really useful, actually. Right, because we have this kind of structure in a lot of places. The AB thing that we need. Yeah, maybe even in FizzBuzz we need it, but for example, we need it here. So we dupe2, right? And now we have extra AB that we can just consume. So we can just do this, right? And then if we just say true, love this. You remember like your first code when you had if true, return true, else return false. It's exactly like this. Okay, yeah. So equals, if it's equal, we'd say true, else we are gonna do false, and that's it, right? Because if it's less than, it's true. If it's equal, it's true. And on the else case, it's false. So we can just say this thing now. So now it's gonna also do 100. Shit. Oh, I forgot that on the else case, we also need to do pop 4 times. Right? Or no, it's only 2 times. Because we already consumed. But is it though? Really, is it needed? So this creates 4 items on the stack. This is gonna consume 2. I need it here in the first thing. And then on the else case, we consume the last 2, and the last else case has everything consumed. So yeah. So now we also do 100, or like less or equal. I mean, following this logic, we can even have pop2, which has A and B and doesn't do anything, and it's just two pops. But which, you know, kind of makes sense, because usually if you do a dupe, you want to do a pop. So maybe here you want to do a pop2 or something. Can we actually use dupe2 here? I think so. Actually, I think so. So it's dupe rot dupe rot. I would say it's dupe2, but then we have to swap here or something like that. Yeah, because we do in, then we are left only with I and n. So we want ni, we want I twice, we do whatever, then we do I plus 1, and then we want in again. And here we want to do a pop2, right? We want to do a pop2 because we have two elements on the stack that don't do anything. Okay, yeah, makes sense. So these are kind of no, it kind of makes sense to build some kind of standard library with all of these functions, even show, modulo ups. I mean, IVEC too, but that's but I mean, yeah, we actually managed to do FizzBuzz, which is quite I mean, I wouldn't say that it is that I mean, it's just, you know, funny that we managed to implement like a real life problem. I mean, it's not a real life problem, but it's like, you know, a well-known problem. I would also do rule 110, but for that one I would like to implement first arrays in the language, right? We could use strings for rule 110. That's how we actually used to do arrays in cool language. We used a string. Actually we can do linked lists. Can we? Let's see if we can actually implement a linked list. So it's because, yeah, if you think about it, in cool language we used strings as the memory of an array, but what we could also do linked lists by using classes. But what if we can do like data node and then say that we have int data and node next? What if we can have something like this, right? And it's more about how we interpreted the types right now, because we don't really have type checking. So yeah, we don't know that this is pointing to itself. I'm curious if it's gonna work. Like, type is not defined yet, but no, we'll do multiple passes through the files. So first we define all the data types, then we define all the functions, and then we check the definition of data types and the function bodies, so we can actually have stuff like recursive types, which in my opinion is kind of important to have. Like, you know, you can actually have linked lists. So let's see. But the problem is, how do we say that the list is null? Like, how do we end it? Right, that's the main issue. Like, would really like to have something like enums, so you can have, I don't know, something like the first constructor and then null, right? So we can have either this thing or null. So yeah, but we can say and maybe boolean, since we already have booleans, right? So let's do a node.init. So we initialize, or I guess node.null, the empty list, basically. So I would say it's gonna be, it doesn't matter, 0, true. And now it becomes interesting, because we need a node. Right, I mean, I could say 0 and it's not gonna complain for now. But yeah, once we have type checking, it's not gonna work. So we'll need a way to actually have different constructors for data types. I think this should work. Let's say node.null pop 0. Let's see if this compiles at least. Wait, what? 71. Wait, I think I made it. Expecting name got end. Oh, okay, yeah. Let's say is null. So it does something, right? Let's do function node.append. So we append some data, right? Int. And it's gonna return a node. So what well, obviously it needs to also take in a node. That's self-explanatory, but I think, no, I think it makes more sense to say node and int. But actually maybe it's cons because we prepend. It's easier to prepend. Let's just prepend. So I'm gonna say so we want to put the number, then false, and then node. So I want to say false swap node. Is that it? I think that's it. False swap and node, because we have false, we swap with the node, and then we call node. Oh, but yeah, I mean, it's true. You can say that. Okay. Yeah, makes sense. Okay, so what if we have then 0, 1, 2. but you have to say like cons for these, then another cons, and then another cons. Right. It's kind of ugly, not gonna lie, but it do the job. Like, fair, you can just use swap to make it a bit more easy to look at, but and let's pop it. Oh, and it's node.com, yeah. Oops, node.coms. I mean, surprisingly, it doesn't segmentation fault or anything, so can we have a print function? Function node show. How would this one work? So int show, where is it? Is like int string. Let's try to make it node into string. So how can I do this one? Let's dupe the node, right? Let's dupe the node, and now let's check if it's null. So node is null. If it is null, then we cannot do anything. But on the else case, we can do something. So we also have to pop. Let's keep that in mind. We can do something like node dot d show. So basically we duplicate the node, we check if it's null. If it's null, we cannot do anything. Otherwise we show the d. So if I node.show string.out, it should probably show us a 1. Oh, or 0, because 0 is the first element. Interesting. But what if we do more than just showing the d? If you get what we also put a comma and we try to show the next d. So this would be string.concat, and then we node.show again, but we have to dupe it. We have to swap, right, to be able to show the node. So now we get another string and string concat. So will this show us 1 to 0, 1, 2, 3? Okay, I mean, close. We were close. I guess the mistake is we forgot something. We forgot to call node.next. 1, 2, oh my, yes, we did it. We did it. So we can actually do linked lists in this shitty ass language. That's kind of cool. It's kind of cool, not gonna lie. Maybe last thing that I'm thinking about is I don't want to show this comma like that. That's ugly as fuck. So I mean, you could check if it's not the last one. Like we just do node next and then node is null to see if we have to do this. I mean, right? Because we want to see if it's the last one or not, to put the comma. Is there a better way? I don't think so. I think that's the only way we can do that. So let's put a new line here. So what I have to do at this point, so here we just show the node, right, on the else case. What do we have to do at this point? Is basically swap dupe, because we need the thingy. We need to say node.next, node is null. If it is null, then we don't do anything. Otherwise, we swap again, so we get the string back first, and we add, I mean, otherwise what do we do actually? We have to swap either way, so we swap at the end actually, right? So here we put the node first, we duplicate it, we consume it. No, yeah, I have to swap in both cases before. It's kind of ugly, but whatever. So in both cases we swap, because at this point we have string node boolean, we consume the boolean, we have string node, we swap and have node string, and yeah, we add comma, so we have a node and then a string. So then we swap again. We could even make it like this, so it's a bit more visible that this entire shit, it's ugly, but it does the job. 0, 1, 2. So how can I make this one look a bit more pretty? Actually, is node.null, and then you put an element, swap node.cons, and then you put another element, swap node.cons, another element, swap node.cons, right? That's the way to make it a bit more pretty. Oh, but that's the reverse way as well. Right, because it builds it in reverse. Yeah, I mean, I guess it's like whatever. Linked list, right? Am I right? So yeah, we don't really need enums to make different constructors, but yeah, this is not gonna work with type checking, right? Because 0 is not a node. In this case, it works because we don't care about it. So that's what I mean by enums. If this thing is true, we don't care about this, or this for that matter. And if it's false, we care about them. So that's why I think I somehow need a way to have different constructors. So you can imagine that you can actually have stuff like null, like here, and then it's gonna give you the option automatically, like the compiler will build you this function, and maybe this one is the other one, node. I don't know, new or something, right? And you can just say node.new to build a real node. So maybe I want to add something like this, but that also means pattern matching and a lot of extra stuff, which I think we should first focus on type checking because I feel like that's gonna be more interesting. But yeah, quite interesting that this thing works that easily, like linked lists. Yeah, I mean, basically have linked lists. But let's be honest, like implementing rule 110 with a linked list, it has to suck. So that's why I say that first I would like to implement arrays, and after that we can think about rule 110 because it's gonna make it much easier with arrays. But I think I'm still gonna push this code in case you want to see how node works. But once it's not gonna work because of type checking, I'll remove it because it doesn't make sense. You know, unless we say this, but if we say this is an integer, then we have other functions that require node. If we say it's somehow a pointer, I don't know, or if we define null as like function null returns an a, and it's gonna be somehow defined in the compiler code. But I feel like adding this null thing would suck. I feel like that's what the Java creator did. Okay, anyway. 3210. Okay, yeah, I mean, fair enough. It's working. A linked list should. And for I guess the last topic of today, because I don't really like to delete stuff from the, I mean, I always delete stuff from this example file. I'd like to keep it somewhere different, and I want to have a lib folder and an stdlib.sl, right? And this stdlib is gonna have these functions, let's say. Probably these come at the top because they are generic, and then come the int functions, and then comparisons and stuff like that. I mean, we can even add something like function and it takes two booleans, returns a boolean. This is the one that I was actually talking about with if, right? If it's true, and on the else cases it should be false. That's how you implement and, right? Two ifs, else it's false, else it's false. I mean, whatever, we'll see. But yeah, for now let's just keep FizzBuzz, and I mean I'll still keep this one. Let's put it like that. So then I'm gonna do 100 FizzBuzz. So right now it's not gonna work because we don't have the stuff, right? But I want to do something like preprocessor import stdlib. Now it's gonna be something else. Expected data func or name. Well, in main.c, somewhere here I said I want to build a dependency graph based on import, right? So I think what we have to do is to add this import. Oh, string slice, yeah. Slice import. I think I want to have it like this. And now we should go to where we parse the st. It should be part of the st if you think about it. So yeah, it should be part of the st. But maybe it's also part of the tokens then. So we can have a special token. So maybe stack token import case stack token import return import, basically. Right, we want to add a new keyword, kind of. So in here, when we parse all the names, right, maybe I want another I don't know why I put it first, but if we have an import, we want to say that we have a stack token import, right? Let's make actually, and let's try to show the tokens of our code. So tokenizer should be good. It should say import and then name stdlib, right? Okay, so it means that we tokenize correctly as expected, but in parse we should say that we can have a data function and a file, but we also add at this point import. So we add this macro preprocessor keyword import. So here we parse import, and maybe we add to imports stack st import. Can I have I mean, could also say that at is a preprocessor macro or something, and then not have just imports, but maybe also like constant variables or something. Like maybe you can have const a is equal to 1. I don't know why would you want that, but something like that, right? And then you do some preprocessor. But I think in C, let's see, you have the facility. Yeah, like maybe that's a different thing. Like if we get an @ symbol, we know we have to parse preprocessor stuff, but if it's not valid, we have illegal token, for example. It's the same as like strings. It's the same thing as strings. but I think I want to have only imports for now, and if we add more, maybe we can think about it. But yeah, right now I don't really care that much. So let's say we can also have imports, because otherwise we can have any kind of preprocessor, and that could make things a bit more tricky, because you would have like token preprocessor or something, right? And then you would have a name for what that thing does, and then some values or something. So then we can implement like an interpreter for that. But I think I want to do it like this for now, only imports. So let's create maybe something like this for the import. So let's go somewhere here, and let's say stack st import. Let me just, wow, stack st import. All right, and import should only have a name. Like, I don't see what else do you want from that function. Right, and now let's implement static void stack st import free. Right, we need a free function, obviously. Stack st import, and this one should just do basically this, only that. It's the only thing we need. So we need import name, and we need to free it, and the other thing that we need to implement is this parse function, which should be kind of straightforward. Parse import, return result, and yeah, because what I want to be able to parse is something like this. It's only these two lines. Yeah, I'll need to figure out. So we want to parse token import, show expected import. I'll have to do these ones better. Probably I'll try to hard code them, and also try to do error correction, because yeah, like probably hard coding them is how you actually do it, because in production, or if you want to implement it properly, you would use a parser generator, like grammar generator, and when that things, you give it like a grammar, right? Probably you know how grammar looks like, or maybe we could cover that soon. Yeah, but you give it a grammar and it generates code for you that does exactly this, right? But since it's developed over many years, it's much better than what I can do. So I think it also hard codes error correction and showing these kinds of errors. So I think I'm just gonna hard code them, but I'll do that on my own, because it's not that interesting. Maybe it's not that great. So let's parse the import. It's gonna complain here, but that's fine. So we read the parser. The error correction, what it should do is that it should just try to find, so for example, if you try to parse and import a function or data, the thing that's like important to find is another data function or import or end of file, right? You have to look for these 4 tokens. If you find one, then oh, I'm safe, I can try to parse again, right? But if you don't find one, then you have to keep looking, because otherwise you'll stack a lot of errors, and that's not that great. So here we have imports, because if you stack a lot of errors, it's gonna look like you have a bunch of errors, but you actually maybe have only one. And that's the problem I had with Cool Compiler, because I implemented it the same way, because it's more fun, to be honest. But for some cases it stacks like 100 errors, so it looks really bad. But for other cases I managed to figure it out, and it never stacks errors. But yeah, so here we do the imports. We also want to free, so after st dump, we also want to free the imports, right? Program imports count, import, we get the ref from imports, and yeah, whoa, stack st import free. So that's how we free the imports. Okay, so we initialize here the st, we add here imports, and here we free them. Okay, makes sense to me. So now we also have these imports. So let's make sure that Lexer works. Let's see if parser works. Right, we have some stuff. It doesn't show the import yet, so we have to go into dump. Where is dump? Here is dump. So we go through all the functions. Let's go through all the imports. Maybe we can do the imports first. So yeah, it makes more sense. Imports, we have stack st import, and we just want to fprintf, maybe like import name value, and yeah, just to not allocate stuff, we are just gonna use this thing, which is really useful. It's like, maybe you want to keep this, like, remember this one, because it's really nice to print substrings basically. So yeah, kind of cool to know in C. Like, I never knew it, to be honest. I just learned it when I started to implement this stuff. Okay, so maybe I want to put another new line at the end, like here, after the list of imports, obviously. Okay, so yeah, this one, you can see now that we have import stlib. So what do we want to do with this import is, so how is this thing gonna work? Type checker should be here. Type checks should happen always. So it's like this. We initialize the Lexer. If you want to see the Lexer results, we just Lexer dump. If you want to see parser results, we just parser dump here. But if you want to see stuff that's beyond parsing, it needs to parse the AST anyways, so we cannot skip it. Now for type checking, when it's gonna happen, we don't have it yet. We still need to do it, but we can just stop it, obviously. and then assembler. Whoa. Assembler needs to be initialized, but obviously if you stop at the assembler stage, you just emit stuff. We'll see. I mean, this is the last stage currently. We do LD manually and fuzz them, so. But yeah, basically after we parse the ST, I would say that we want to merge all the ASTs. So program, if you take a look at, let's go to stack AST import because that's the smallest one. We have this stack AST node which has a reference to its parser. Right. So we need this kind of preprocessor. Track preprocessor init. Right, we need to initialize the preprocessor, and that's something that we need to create actually. So we preprocessor. But it's at this stage, stack preprocessor. No, it's this is an extra step from cool language. In cool we didn't have a preprocessor, so let's see. So stack preprocessor init. What do we have to do is stack preprocessor, maybe like parse or run, and I should give it preprocessor and program. So if this thing is not equal to 0 for some reason, return defer 1. So what I think the preprocessor I wanted to do is to add more stuff to the program. Right, so that's what I think I wanted to do. Okay, let's go to, so here should be the preprocessor. Right, so we need, let's do like type def struct stack preprocessor. That's gonna be the name. And from what we've seen, it should have a reference to the program. Or no, it's not needed from what I can see. But we need that void stack preprocessor init stack preprocessor, and it looks like, yeah, that's the function that we need. It's like parser init. But yeah, I'm not sure what it should have on it. Right, and then we need a void preprocessor run. The name is stack st. We have prog, yeah, stack st prog. So we have the run function, which should actually be an int. Yeah, so it should return int. So what is the preprocessor gonna do? Well, we just care about the imports. We just care about the imports. For now, let's say that the imports won't be recursive, like in because we need to build the dependency graph and like build dep graph and like to do make sure no cycle, right? Like cyclic, how do you spell it? Cycle import. You cannot have, you know, cycles in the imports. That's not gonna happen. I'm not gonna do something like oh, let's ignore the cycle and just ignore it. No, if you have a cycle, it's gonna fail. It's gonna be like Golang. Right. It's not gonna be a JavaScript bullshittery. But for now, let's imagine that we just import a single thing. So what we want to do is that we'll need a lexer and a parser. Right, we'll need a lexer and a parser. And you know, it's gonna be a recursive preprocessor, but for now, let's just imagine that that we don't. So we'll have something like this at some point. Oh, we also need to define the buffer and buffer length. Yeah, fair enough. But let's imagine that we have only one import or something, and it's gonna be easy. So we do something like for unsigned int I is equal to 0, I is less than proc.imports.count, because yeah, even solving this is gonna be interesting, but I mean, we'll see. So obviously we want to read a file. We get that file name from the thingy. So let's no, it's stack st name, right? Or what's in the imports? Imports, oh, it's stack st import. Import, let's say it's equal to 0 or something, and then we just do like ts dynamic array get. We get from prog imports into import from index I. This can fail, but again, it's not really gonna happen. It's like impossible because it fails only if I is greater than count, and you can see that it's not the case. Okay, and something interesting. We actually need to allocate memory. Right, we have this named value. We cannot really use it here. Right, we don't use string slices in DSI or read. We use an actual file name. So we have to ds string slice to owned, ds string slice to owned, and here we need to say file name. And what I'm actually gonna do is put file name here. We'll handle the things afterwards. yeah, if this fails, it's out of memory, I don't care. So then we try to read from file name into buffer. Here it's always going to be file name, so yeah, fail to read file name. Yeah, maybe what's gonna be kind of interesting is I mean, I'll put a path in the name, so it's gonna be fine. Okay, so fail to read from file. We'll see how that looks like. Right, but at this point, we can initialize the lexer. We can initialize the parser. And we need another program. We need another program. So I'll call this one program import. Program import. Oh, what's interesting is here we delete the arrays, but if we didn't, then maybe we could have just, you know, just pass the program and I could make a function void stackast prog init, stackast prog, and it will just call these functions. All right, and now you are supposed to call init yourself. We have stackast dump, stackast free, so maybe it's going to be stackast init. I went past it, right? How did I? Okay, stackast init. So you are supposed to call stackast init before you call parse, I think. All right, so I think I'm gonna do stackast init prog, and then you parse, and parse is not gonna initialize that for you. So here I can actually just put program like this, right? So we don't need this. So it's just gonna add stuff to it. But you know, this is not really ideal when we'll have nested stuff. So maybe it's not good anyways. But I feel like maybe parse shouldn't initialize the program though. Like maybe having it separate is better. Let's just say that. Let's just cope that that's better. So what's interesting at this point though is we cannot free the buffer or the file name, and that's because the parser once it's using the file name here, and then the AST is gonna use the buffer for the string slices. So problem is that this buffer needs to, you know, speaking in Rust terms, needs to live as long as this program. So, and this program is freed. Wait, where is it freed? It's not necessarily freed, but it's not being used only at this point, right? Like it's being used in the assembler, it's being used in all sorts of things. So that's kind of bad. But let's see if we have any memory leaks before this. So let's make boohoo. Really? Cannot I say just equals to 0? No. That's annoying. So if I parse, I forgot, it's not gonna work. But at least we can see if it has memory leaks, right? Oh, it has some memory leaks. Where though? Let's show us. Really? I have to do leak check fulls to show that. Leak check full. So in dynamic array append, when we do stack parser parse. Wait, when do I do that actually? What? So it's doing it in realloc. I'm missing a free, right? 939. Yeah, when I append imports, obviously, here is where I allocate. Oh, yeah, I should say imports. Yeah, that was a good catch actually. See, it's kind of useful to use this thing. Okay, anyway, let's turn on the preprocessor, which right now won't really work. If you ask me, it won't work. So if we make and we just try to run the assembler, well, if we try to run the parser, it's gonna work that, but the assembler is not gonna work because it's failed to open this file. And what we have to do, which kind of sucks, is lib/sl. But I want, you saw how I want it to look like it's much nicer. But I think this worked. But you can see the error is shown actually in the file itself. So that's so much better. But I have an error in stdlib. I wonder where. 46. So this thing, it says that it expected end and got if. What? Expected end got if. That's the most strange thing I ever heard. Let's delete this. What? Oh, no way, oh shit, and it still works. Well, what can I say? I mean, obviously expected that. Yo, but this one is a bit sus. This one is a bit sus. So let's check out a bit the parse. So when we parse a function, right, we parse func name some nodes, we parse in, then we check if it's end, and then we parse expression. Maybe I messed something up in the if statement or something. Let's do like only this, because this is Like that should definitely work. Yeah. So then oh, I think I know what I did wrong. I think it needs to be like this. So this is an if and that's the other if. Okay, yeah. Okay, yeah, that was the problem. So now you can see that we have an example. We import lib.stdlib and yeah, basically we just have imports now in our language. So we can just move code into stdlib. But again, that's not yet finished because we need to do dependency graph, make sure we don't have any cycles, actually like check all the, I guess, yeah, we first need to parse everything and then combine them at the end, not exactly like this, but for now, you know, this works. And another thing that we need to do, which I'd like to have, is if you import from lib, you don't have to specify that, and the extension should be automatically understood. I mean, that we can just do easily. But I want to have something like, you know, Python path, right? Environment variables. So I want this to know where to search, right? It needs to search into the lib folder of the current directory, or lib of like OS, or the current directory, or same order as C. So how are we gonna do that? Usually at this point is, well, we allocated the file name. Okay, so file name is not needed out there because I'm not gonna free it, because I cannot free it actually. Okay, so we have file name to owned, but maybe I want actually to have ds string builder sb, right, and ds string builder init. Let's initialize it, and then we can do string builder append sb, and here we can build our lib slash percentage dot star s dot sl, right? But now it's hard coded. As I said, in the future you want to search in multiple paths until you find it, and if you don't find it, then that sucks. So import name value len, import name value str. The string builder build sb file name. So now in example we should be able to say that, and yeah, I mean, I guess I'll do like memory handling at some point. Make, right, and it still works even with the new import where you import stdlib. So I'd say that's kind of cool. Why do we also get the linked list? Yeah. Let's put also new line string out. So we just implemented imports like preprocessor macros, right? Yeah, I think that's decent. That's pretty cool. So again, this should be like in the current folder, in lib, in I guess it's user lib or something, you know. I don't know how to do it on Nix, but probably Nix as well has some stuff. But I think I'm just gonna leave it as lib. So yeah, but yeah, it's gonna be interesting to build the dependency graph, because we have to read all the programs, right, separately, merge them together, have like a graph data structure probably. So we'll see how that works. Okay, so let's remove that too, because now we actually have a function that that does that. All right, so one other thing I want to do, because I don't like not initializing stuff, is actually because you see here I put like an int a for now, just to have something. All right, just to have something. Okay, so it no longer complains, but yeah, we have to build this dependency graph, but I think I'm gonna leave it for later. We're not gonna do that soon enough, because to be honest, more than stdlib we don't really need, I think. So I don't want to overcomplicate stuff for things that we don't really need that much at the moment. Something that we actually need is type checking. It's gonna make things a bit easier, right? Traits, again, they are gonna be pretty late, maybe even after we do the dependency graph. Because it's gonna be easier to implement dependency graph, I think, before we have a lot of stuff in the language, probably. Right, this refactoring is just nice to have, I would say. It's not really important. Do we have other to-dos? So it's this is a type checking, and yeah, this one, which now is gonna be like a big problem. Like if we check the memory of this, it loses some stuff in 4 places. So because we can identify which those places are, right? Once it's gonna be the string builder structure, which we can free, it's no problem. The other one is the file name, and the other one I think is the buffer. And is there another one? Like it looks like it's another one. Really, what? Click check full, yeah. So I'm not sure where though. I mean, obviously it's like I said, one is going to be the string builder itself, one is going to be the build function of the string builder. Oh, I guess this is IOREAD actually, the buffer. But yeah, I mean, so string builder build, IOREAD, string builder append, because it does the realloc, and stack lexer next. it has a dynamic array append at some point. Interesting. Inside of stack lexer next, that's 252. Strings. Oh, we have a string probably, right? In the standard library. So if we look at stdlib, we probably have this string that needs to be allocated by the compiler when we, I mean, even this string is actually gonna be, oh, but there are more strings. All of them should be freed. Oh, it says it's probably 21 or 24, 13, right? That's the number actually, because you can see it's 24 bytes. So it's like 12 of them are 2 bytes and one of them is 0 bytes or something like that, which sounds weird, but right, because we have probably 12 of one character, right? 10, 11, and this is the 12th one, and another one here. Oh, so it's actually 11 of 2 characters and 2 of 1 character, right? Yeah, that's how it is, right? So we have to free those things, but again, I think we cannot free them. So if you think about it, I don't think we can free them in the run function. So that's what stack preprocessor might need. It might need a list of lexers and a list of parsers that we need to free at the end of the execution, because those strings are needed at the assembly time, so we cannot free them here, we cannot free the lexer here, we cannot free the parser. So yeah, that's what I think is gonna be needed. Yeah, but I mean, even here program, I think it should be like a different structure. Yeah, I guess that's what we'll need here. Maybe we can just do that quickly, like, why not? Shouldn't be like impossible to do, but yeah, let's see. So we can have lexers, parsers, and stack parser free. It also does stack lexer free, so yeah, I don't know if I want to keep all of them, but wait, one sec. What if I remove that free there? It's still the same thing, right? So we don't really need to free the, I mean, at the same time, AST free, because you know that might as well just call free. So if we go to the, I don't know, import free and then node free, a node has the parser too. So like it could just free the parser itself, right? But I don't know, stack parser free, if it's gonna explode if you free it so many times. I don't think it would explode actually. right? So we could just free the AST, and in the AST we free the parser, but that feels a bit weird. Let's try that. Let's actually try it, because it's my, yeah, it could be quite nice. So we free node parser, right? So if we make and we run it, we have errors, but the errors are multiple frees or what? Yeah, I mean, I don't know, it's stack lexer free 337, right? Because here we read it once, maybe that's not the best idea, right? Because we call this thing here, so it's always gonna have a reference. Yeah, I don't think this is a good idea though. Right, to call free on the node parser, because you don't know if it was freed or not. And problem is, so you set all of these, that's fine, it's not a big deal. But let's say you free lexer, but yeah, I'm actually curious, what why do we have an error like that? Because this free function just sets some things to 0, that's not relevant. This thing just sets some things to 0. And it's like lexer strings count. So why does it say it's jump on uninitialized value? Because this just frees the allocator, or I guess the items, if the items is not null, and here items becomes null, and then count becomes 0. So it's, I don't see how like, where does it depend on uninitialized? Dynamic array get, so 339, but I set the count to 0, right? So why does it try to get the value? Like when you do dynamic array free, it says the count to 0. Stack parser free 4 to 6. Yeah, but why? Oh, buffer overflow. What? Three. Yeah, I really don't understand why it's because I call stack lexer free only here, stack parser free only here, and stack ast node. Maybe stack ast node is called multiple times. I mean, it is. but it's like called only here. Yeah, I don't know what to say, like the freeing of the memory is the hardest part, you see. Like obviously this thing is gonna be called so many times, right? But I wonder, oh, it's because here I made the parser null, so I should say if node parser is not null, we call the free function on the thing, right? Or yeah, because otherwise it's null, right? Not like it's gonna be called again though, but stack parser free. Here I could do something like parser lexer is equal to 0, or lexer is that. Okay, so I can say, right, I can make it 0, for example. So maybe like if parser dot lexer, oopsie, is not equal to 0. Is that a thing? I mean, I guess it's not made for that, but I could do like buffer, it's not null. But honestly, that feels wrong. So I'm just gonna do it like this. You call stack lexer free. And then, but I don't know how the count is not 0 for this strings array. Oh, is it because somehow, yo, I think, yeah, it's because here when we initialize the parser, we send the lexer as a value. Right, ideally you would want it to be a pointer though, but this is gonna break so many, it's gonna break it in so many places. Right, it's gonna go insane mode. It's like, oh shit, everywhere is gonna be broken. Like here you have to do it like this and then set this one to null, and then maybe like if parser lexer is not null, then you call to this. But what, it's not broken in more than one places? The fuck? So why is that? Because here I changed it to be a pointer. Maybe I was just lucky, like maybe stack parser peak. Oh, it's only called here, I guess. Right, it's only called there. Okay, that makes sense. So now it means that here we pass a reference of the lexer. So it's no longer a copy of this, so it's exactly the same lexer, right? So that means that stack st free here we have a reference, so we can do that and create, and here it means that this is gonna be fine. But I have some compiler errors as well on 170. Here we need to say it's a reference. What? Fuck. Let's see. Oh shit. Well. What tech FST note 426. But where was this one called? Stack parser free. Or is it like stack lexer free? I guess, is it because of the import? Yeah, it's because of imports now. So if we go to main, in type checker init, don't do anything special though there. So yeah, I mean, I guess it's because of preprocessor run. It's because these are allocated on the stack, so are gonna be removed once you go out of the scope of this function. Right, so here when you do stack lexer init, it's fine, you parse it, it's fine, but once you go out of scope, they are being freed. But what sucks about that is that they are actually needed. So that's why I said maybe I want these to be like stack lexer and stack parser, and yeah, we'll have to do them like this. But let's see, this dynamic array init processor lexers size of stack lexer. I think I want them parsers. It's gonna be parsers, dude. Stack parser, maybe like this. And yeah, what if we add them to the list somehow, and then we take the reference, right? That's what I'm thinking. But I mean, that's I don't know, like, to do another time. I would say, like, I'm just gonna do this for now, and yeah, it's gonna leak the memory, obviously. It has errors, but it's just memory allocations. I don't think it's anything serious. So for now, let's just not worry about memory allocations, and just, we have FizzBuzz, we have linked lists, we are able to import from stdlib. So I would say this is pretty nice. I'm just gonna try to do free stuff on my own because it's pretty boring, to be fair. So yeah, hopefully this was more useful, because we implemented quite a lot of things. And yeah, see you in the next one. So see you.